Today I am going to discuss a new model which is column base. In case of RCC structure, we used to tell this as a footing or foundation, and in case of steel structure we will say this as a column base. That means, column is placed on certain base through which the load from superstructure is going to transfer to the soil through this substructure. So, column base is basically consisting of column and base plate and an anchoring assembly. So, these column base are two types, one is called slab base and other is called gusset base. So, in case of slab base, we generally when the load is coming concentrically and magnitude of load is comparatively less, in such cases generally we use this slab base, and in case of gusset base the load is generally eccentric in nature and magnitude of load is high, comparatively higher. So, for such cases we generally prefer gusset base. So, today we will discuss at the first lecture about the slab base. Now, in the column base, the main function of the column base, as I told, is to transfer the loads from column to its foundation, and for that we need a spreading area through which the concentrated load from the column will be spreaded to the soil through some medium which is called base plate. That means, column will be rested on the base plate. So, the concentrated load coming from the column will be distributed over the base plate, and then base plate again will be rested on the concrete block. That concrete block will be again rested on the soil. So, stage by stage the load will be distributed from superstructure to the soil, right. And the slab base is basically consist of a thick plate of steel material, and this thick plate is connected with the column through some angle which is called cleat angle, and that connections are made either by bolt or by weld connections. And slab base, as I told, are basically used for means it will be suitable for light loaded column only, and it will be economical if we use for light loaded column, and that base plate will be either welded to the stanchion or would be joined to the column through cleat angle, right. And design of column base plates requires consideration of bearing pressure on the supporting material and bending of the plate. Now, let us see the general assembly of the column base, means the slab base. So, say for example, in this case a I section is transferring load from the superstructure. Say it may transfer load, concentric load, and also it may provide some, means it may transfer some moment as well, and then we provide a base plate of steel material. So, this is called base plate, and this base plate is connected with the column with cleat angle. Okay. So, if it is concentrically loaded, then the minimum number of cleat angles are provided, minimum number of bolts are provided to connect the cleat angle with the column, otherwise we have to design, and here we provide anchor bolts. Okay. Now, after means below the base plate, the load is again spreaded to the concrete base. This is called concrete pedestal. So, load coming from base plate is again transferred to the concrete pedestal. This is concrete pedestal, right. So, different grade of concrete may be used depending on the magnitude of load and requirement of the thickness and requirement of the dimension of the block and dimension of the plate. So, this is, we can say, this is front view, means front view of the slab base. If we see, it will look like this, and this anchor bolt will be provided to connect the base plate with the concrete pedestal. This is called anchor block. So, anchor bolts also will be designed as per the requirement, and if we see the same in top view, it will look like this. So, this is called width of the pedestal and this is the length of the pedestal, right. And if we see the plan of the base plate will be like this. So, this is base plate and this is width of the base plate and this is length of the base plate, right. Then the column is provided. So, for example, these I section columns, its top view will be looking like this and column is connected with the cleat angle, right. So, we can provide nominal number of cleat angle bolt which will connect the cleat angle with the column, right. So, this is column and this is top view. So, this is a top view of the slab base system and this is the front view of the slab base system. So, what we need to design is, one is what will be the size of the base plate, that means length, width and thickness, right. So, length of the base plate we have to know, and that can be found, length and width can be found from the grade of concrete, means how much area we need to have of the base plate, so that the area can be transferred to the concrete pedestal without any failure, means sufficiently it should have, so that the load is transferred from column to the concrete pedestal. Again, the dimension of the concrete pedestal depends on the soil, means soil properties. So, we need to know the bearing pressure of the soil. So, according to that we have to find out what will be the length and width of the concrete pedestal required, so that the load is distributed and transferred to the soil properly, right. So, this is how the system are made, and in this way we have to design the base plate due to this concentric load and moment. And this moment we can see that because of this uniform pressure from the concrete to the base plate. So, here also uniform pressure will come from the concrete to the base plate because of the concentric load. So, the maximum bending moment will be occurring at the face of the at the edge of the column. So, at the edge maximum bending moment will occur. So, we need to know what will be the projection in both the direction. Say in plan we can see the projection from this direction, it is, say we can say B, and projection in this end will be, sorry, this end will be, say, A. Okay. So, A and B are the projection in both the axes, and because of this projection the bending stress will develop, bending moment will be developed at the edge, and we have to calculate the bending stress, and then we have to find out its influence, so that we can find out the thickness of the plate accordingly. So, to find out the thickness of the plate, what we can do, we can find out what is the bending moment coming. So, if we see the column is rested on the base plate, and the base plate is having uniformly distributed load coming from the concrete. So, this is W, right, and at top view if we see, the column is something like this. So, projection means the base plate is like this. So, the projection will be, this is A and this is B. So, bending moment, maximum bending moment along x axis will be, maximum bending moment along x axis we can consider that W is the length, means W is the unit pressure from the concrete, okay, W. So, bending moment we can find out W into per unit length, we can find out W into 1 into A by 2. Okay. So, W a square by 2 along x axis. So, if we consider this is x and this is y. So, along x axis we can consider that bending moment is coming, sorry, this is A. So, W a square along x axis we can consider this, along y axis we can consider this. So, W a square by 2, and in the other direction we can consider, say, m dash is equal to W into 1 into B by 2. So, W b square by 2. So, the maximum bending moment at this point, about two directions I can find out. So, the effective moment we can find out in one direction, that will be, so effective moment I can find out as W a square by 2 minus mu into W b square by 2, where mu is the Poisson ratio, and for steel we can consider mu as 0.3. So, I can consider W by 2 into a square minus 0.3 b square. So, maximum effective bending moment can be found as W by 2 into a square minus 0.3 b square, where A is the longer projection and B is the shorter projection. Okay. Now, the moment capacity of the plate I can find out, say plastic moment capacity M p will be 1.2 F y into Z d, right. So, where Z d is the elastic section modulus of the base plate. So, we can find out Z d as 1 into T square by 6 for unit length. Z will be B T square by 6. So, B is 1 here. So, we can find out M p as 1.2 F y into T square by 6, right. So, now if we make equal to the load due to, means moment due to the pressure, then I can find out 1.2 Fy t square by 6 is equal to W by 2 into A square minus 0.3 B square. Now, we have to multiply the partial safety factor. So, taking the partial safety factor into consideration, we can consider 1.2 Fy by gamma m 0 and into t square by 6 is equal to W by 2 into A square minus 0.3 B square. So, from this I can find out t square as 2.5 W into A square minus 0.3 B square into gamma m 0 by Fy, or the thickness of the base plate can be found from this finally 2.5 W into A square minus 0.3 B square into gamma m 0 by Fy, right. So, this thickness of the base plate also is available in the code. So, this formula you can find out in the IS 800 2007, where it has been told that T is equal to square root of 2.5 into W into A square minus 0.3 B square into gamma m 0 by Fy. So, this is how we can find out first length and width of the base plate from the pressure, requirement of pressure means what is the load, total load. From that I can find out what is the bearing pressure of the concrete, also we can find out. So, load divided by bearing pressure is equal to area. So, from that I can find out the length and width, and also I can find out the thickness from this. So, this is how we can find out the dimension of the base plate, right. Now, we will find out some certain steps, we will see what are the steps required to design a base plate. Okay. So, if we see the steps, first what we can see, we can assume suitable grade of concrete, means what grade of concrete is going to be considered, that we will assume. Okay. And we are assuming that the pressure is distributed uniformly, okay. Because of load, the pressure from the concrete is coming uniform, okay, at the bottom of the plate. So, and also as per the assumptions of the grade of concrete, we can find out the bearing strength of the concrete. Bearing strength of the concrete will be 0.45 FCK. So, if we assume the grade of concrete, then we can find out the bearing strength of concrete. So, from this what we can do, in step 2 we can find out the area of the base plate. So, area of the base plate we can find out the total load P by 0.45 FCK, right, because 0.45 FCK is the bearing strength and P is the total concentrated load on the column. So, the base plate area we can find out from this, okay. And remember this P is the factor axial load. So, we have to multiply with factor and we have to find out the P value. Now, after getting the required area, we can find out the size of the base plate. Size of the base plate means what will be the L and B. Either we can provide here a square base plate, right, or we can provide with certain length and breadth ratio, okay. And for economy, as far as possible, we need to keep the projection A and B equal. Why? If we see, suppose this is a base plate. Now, if this is the column, then the projection A and B, if it is different, then the along the larger direction, along the larger projection, the maximum moment will occur, right. So, moment will be more along the larger projection. However, if we consider projection equal, then what we can find out, then projection will be little less we can make, and also as we know A square minus 0.3 B square, the moment the thickness when we are going to find out that there a term a square minus 0.3 b square. So, if we try to keep a and b as much as equal, then it will become minimum. Okay. So, to make economy, we will try to keep the projection length a and b as much as possible equal, right. Then in step 4, what we can find out? We can find out the intensity of pressure W, actual intensity of pressure W, that is P by area of the base plate, area of base plate. So, this area of base plate is different from this, because this is the required area and this we are going to provide, which will be little higher, and this we are providing with consideration certain length and breadth of base plate, right. So, from that we can find out the intensity of pressure from the concrete pedestal. So, after step 4 we can find out, that means in step 4 what we could say, we could find out the intensity of pressure on the basis of assumed value of L and B. So, L and B is determined. Now, in step 5 we can find out the thickness, minimum thickness required. So, minimum thickness will be found from the formula what we have derived earlier, that is 2.5 W a square minus 0.3 b square, right, into gamma m 0 by f y, right. So, minimum thickness required on the base plate can be found from this formula, which is given in clause 7.4.3.1 of IS 800 2007. So, in clause 7.4.3.1 the minimum thickness of the base plate is found, and it has to be greater than thickness of the flange of the compression member. So, the thickness of the base plate at least has to be greater than the thickness of flange of the compression member, that also we need to check, right. Then in step 6 what we can do, we can provide 2 to 4 nominal bolt for holding down the cleat angles. So, what we can do, so the column is rested upon the base plate. Now, we will provide a cleat angle. In case of concentrated force, the nominal angle size will be provided, and to hold that we will provide nominal number of bolts, that is 2 to 4 of 20 mm diameter bolt. Okay. And if we provide the weld, then in step 7 we can find out the weld length connecting to the base plate with the column. That weld length means the, we will see, say for example, if the column is connected with the base plate, then we will find out what is the weld length, available weld length, and what will be the required weld length. So, from that we can find out the size of the weld length, weld and other things, right. So, this is how one can find out the detail of the base plate, right. So, in short, if we see what we could see here is that the load from the superstructure is coming to the soil through the substructure, which is made of base plate and the concrete pedestal, right. Now, concrete pedestal will be decided, the dimension of the concrete pedestal will be decided on the basis of the soil bearing pressure. Similarly, the length and breadth of the base plate will be decided on the basis of bearing strength of the concrete. So, what grade of concrete we are going to provide, depending on that we will find out the length and breadth of base plate. So, once we find the length and breadth of base plate, then we can find the thickness of the base plate, and thickness of the base plate can be found on the basis of the moment, and that moment has been calculated from the maximum means from the projection. So, we will see what are the projection is there, and at the column face what is the maximum moment is going to develop. On that basis we will find out the minimum thickness of the base plate required, and that expression also is available in the code. In 7.4.3.1 clause we can find out that formula. Okay. So, once we find out the thickness of the base plate, so dimension of the base plate is decided. Dimension of the base plate means length, width and thickness. After that we will provide for concentrated load, we will provide the nominal number of bolts to hold the column in position with the base plate through the cleat angle, and cleat angle size also will be nominal, and then through anchor bolt also we will fix the base plate with the concrete, right. So, this is how step by step one can design a base plate. So, in next day we will go through one example to see how the base plate is designed. Thank you.